Just when everyone thought supernovas were the most powerful explosions in the universe, a kilonova was captured in an image by Hubble Space Telescope, and scientists are stunned by what they see. A kilonova is a rare astronomical phenomenon that occurs when two very dense stars are orbiting one another very closely. Their emitted light becomes so intense that the stars begin to break down, resulting in a supernova explosion. Kilonovae are thought to be 1,000 times brighter than normal novae and 100 times more powerful. So how did they come across this amazing explosion? When these two deadly stars collided, what did they observe and how powerful is a kilonova? Before we plunge into the truths behind this cosmic phenomena, hello and welcome back to the Discover Space channel. Make sure to hit that subscribe button to keep up to date with the most intriguing space discoveries. Neutron stars, the incredibly dense remnants of exploding stars. When two neutron stars collide, it can be so incredibly bright that some scientists have coined the name Kilonova. Kilonova got its name from its stunning peak of brightness, which is thought to be around 1,000 times brighter than a regular nova. But even though it doesn't compare to a supernova, it is still 100 million times brighter than our own sun. When two neutron stars crash, more energy is released in a fraction of a second than the sun will create in its whole 10 billion year lifespan. A kilonova is not only unbelievably bright and beautiful, but it is also extremely significant to the universe. This is because a kilonova ejects elements like gold and platinum into deep space. Normally, the largest remnant of a kilonova is a black hole. However, the Hubble Observatory has discovered something more startling than a black hole. Gravitational waves called GW 1708-17, created by a binary black hole merger, was observed for the first time on August 17, 2017. Around 2 seconds after the gravitational wave was detected, NASA's Fermi Gamma Ray Space Telescope saw a brief gamma ray burst in the same direction. Astronomers discovered this in the galaxy NGC 4993, 130 million light-years from Earth. A bright point of light flashed brightly where nothing had previously been observed and triggered the world's largest multi-telescope treasure hunts. Despite the fact that such mergers have been speculated about for over 30 years, this is the first proven instance. Using Hubble's high-resolution imaging capabilities, scientists were able to gain the first observational confirmation for a kilonova. Hubble took optical and infrared photographs of the galaxy far away and discovered a new sparkling field of light within NGC that was fainter than a supernova. When NASA's Hubble Space Telescope was allowed to alter its course and point toward the merging event 3.5 days after its detection, researchers determined that they were witnessing the formation of a MAGNETAR, a highly magnetic type of neutron star. This was the only way scientists could explain the infrared light 10 times brighter than expected for most mergers. As the MAGNETAR rotated quickly in this merger process, the magnetosphere transferred energy to the debris created by the explosion, causing it to glow in a way that became visible to Hubble's infrared instruments. Despite the fact that this kilonova is located in a galaxy far away, the revelation has implications for our lives on this planet as well. Previously, nuclear reactions in supernova explosions were thought to be the source of heavier than iron elements, many of which found their way onto planets. Neutron star mergers are believed to be the source of many of our heavy elements. What more mysteries lurk within this bizarre and devastating union of two neutron stars? The next stage is the James Webb Space Telescope, which recently arrived at its final destination on a mission to study the cosmos. If another spectacular burst occurs, That instrument will be able to not only monitor, but also capture a spectrum of its afterglow. It will be able to determine the exact components produced by the kilonova. The James Webb is the most advanced telescope ever built by humanity. It features technologies and imaging equipment that will outperform its predecessors. It should be termed Telescope 2.0 in many ways because it is so far revolutionary for its time. Now consider what astronomers might learn about kilonovas if James Webb or other future telescopes were to observe one. Kilonovas are responsible for many of the world's most significant and valuable components, but we have yet to understand their full significance. Kilonova occurs so occasionally but produce such spectacular outcomes is the main reason why scientists are continually searching the heavens for more. They know that these two neutron stars colliding and exploding in a furious display of might and power contain a plethora of information. And that's it for this video. Thank you so much for staying in tune with us as we give you space discoveries you'd really want to know. Comment down what other cosmic truths you want to uncover, and we will see you in the next video.